Hello there guys. Okay, welcome to my channel. Okay, in this video I'm going to explain to you about chemistry paper 4 43 May-June 2021. The time duration here is 1 hour and 15 minutes. Okay, let us start with the first question. Okay, now for the first question, give the name of the process that is used to produce large molecules from monomer. Okay, large molecules from monomer. It means this one is a polymerization. Okay, it is a polymerization. So remember, polymerization we have two types. One is a condensation. Another one we will have a addition. Okay, but for this question, only polymerization is your answer. Okay, the next one, to separate oxygen from a liquid air. Okay, this one we are going to use is a fractional distillation. Okay, C, to make ethanol from glucose. This is a fermentation process. Okay, the next one, D, to separate water from aqueous sodium chloride. Okay, aqueous sodium chloride is a soluble salt. Alright, so to separate the water, we need to, to separate the water from aqueous sodium chloride is the distillation process. Okay, so let me show you here. This is the distillation process where here is the aqueous sodium chloride. So once it gets heated, the vapor, the water vapor will be condensed at here in this Liebig condenser, and here we will have the water. So this is called as a distilled. Okay, so please don't confuse between a distillation and also fractional distillation. Okay, the next one, to produce aluminium from aluminium oxide in a molten cryolite. Okay, this is electrolysis. Okay, F, to separate the product of a hydrolysis of a long chain carbohydrates. Okay, this sentence here is quite confusing, so you really have to understand this. Okay, now if you look at the polymers, now example we have here A, and you will have a product of a B plus the water. Okay, now this is the example. Okay, this is the example of a polymer. So the type of polymer here is a condensation polymer. So example, this is a amino acid. Okay, this is an amino acid, and here's the same type of amino acid. And here when they combine, this will form a protein. Okay, so from the reactant to the product, here we will have a condensation process. Okay, condensation process where it will remove the water molecule. So when you're doing hydrolysis, okay, look at the sentence here, product of hydrolysis. So it means that hydrolysis, okay, the carbohydrate, if it is a carbohydrate over here, here should be the glucose. Right? Here should be the glucose. So it means that, okay, if you look at it properly, to separate the product of hydrolysis, what is the product of hydrolysis? Is the glucose, right? So to separate the glucose and amino acids here, this one, the most suitable process here will be the chromatography. Okay. Okay, so please don't get confused with this one. Okay, then now for the G, to separate an aqueous solution from an undissolved solid. So this is definitely a filtration. Okay, this is a filtration process. So total marks for the first question is 7 marks. Okay, now let us move to the second question. Okay, number 2, complete the table to deduce the number of proton, electron and neutron in the boron atom and chloride ion Identify the atom or ion represented by the final row. Okay, now let us make the table bigger. Alright, so now, okay, the proton. So down here must be the proton. It's too big. Okay, it's just nice. So here will be 5. Okay, since it is an atom, so the proton and the electron must be the same. So here neutron. So neutron here will be 11 minus with 5. So we will be getting here 6. Okay, now here it is an ion. Okay, if you notice, it is an ion here. So what we should do here, if we take 17 is 2.8.7. This is the electron arrangement. So for ion, it has to be stable. So here will be additional 18, additional 1 more electron. Okay, so neutron will be following nucleon minus with the proton. So here we will be getting here 18. Okay, so now if you look at the next one, the proton number and the electron number is not the same. So definitely the elements, the formula here will be an ion. And if you notice again, the proton has 3 more compared to the electron. So here will be something to do with the 3 positive charge. And here will be 24. And the number of neutron is 30. So 30 plus with 24. So here we'll be getting there about 54. So here we need to find an element of 54 and 24. So let us look at our periodic table now. Okay, so this is our periodic table here. So what is given to us is 54, 24, x 3 plus. Okay, so it's definitely going to be a metal. So we try to look for 24. So 24 definitely in this area. So it's 21, 22, 23 and 24. So what is this? It is a chromium. Okay, it is a chromium. So now we go back to the question. So the answer here is chromium, Cr. Okay, that is for 5 marks for this question. Okay, now for number 3. Sodium react with fluorine to form sodium fluoride. Okay, write a chemical equation for this reaction. So sodium, it appears as a single. Fluorine, okay, fluorine, it appears as a F2 in a room temperature. So when they combine, they have an ionic bonding. Now we just have to balance the equation. So here's 2 and here's 2. That's it for 2 marks. Okay. Now sodium fluoride is an ionic compound. Yes, it's a metal and non-metal. Complete the diagram to show electron arrangement in the outer shell of the ions present in the sodium fluoride. Okay. Okay, so for our understanding here, sodium has about 11 electrons. Okay, so we have a 2.8.1. So they will donate 1 electron to form 2.8. So we just have to follow the cross. If they have a cross, just follow the cross. We need to fill up 8 electrons over here. And we put a positive charge. Okay, we put a positive charge over here, positive 1. Now look at fluorine. Fluorine is they have 9 electrons, which is 2.7. So they will accept 1. Alright, they'll accept 1. So which will give them 2.8. So you will have 7 electrons as a dot. Right, 7 electrons as a dot. And 1 will be coming from here. So you can do an arrow like this, across. Okay, it is being donated. So this one is donating electrons, and here will be receiving electrons, and here will be a negative charge. Okay, so I hope you understand this. So this is a 3 marks question. Okay, now the next one. Aqueous sodium fluoride undergoes electrolysis. State what is the mean by the term electrolysis. So we can follow this. It's a breakdown of an ionic compound or substance. Make sure you write here in molten form or in aqueous form. You can put O here, by electrical energy. Okay, by electrical energy or electricity, depending on you. So this is the meaning of a electrolysis. Okay, so next question, they are asking the name of the product formed at the positive electrode and negative electrode when dilute aqueous sodium fluoride undergoes electrolysis. So let us do this experiment. Okay, now let us write down all the ions that they have here. Okay, they have sodium, they have hydrogen, they have fluorine, and they have a hydroxide. Okay, so okay, this is anode and this is cathode. So anode will be at the positive side and the cathode will be the negative side. So over here we need to follow the electrochemical series. So here you have a hydrogen for cathode, and hydroxide will be discharged at the anode side. Okay, so please remember the equation. If you have hydroxide, you will have water plus with oxygen. Okay, and remember there is a 4 electrons here and 4 over here. Once you balance, you'll be getting that 2 water. So at this anode, you will have oxygen gas released, and at the cathode side, you will accept electrons to form hydrogen. So here we will have hydrogen gases. So this is the results of this experiment. So here we do have oxygen, cathode is a hydrogen gas. Okay, so now let us look at the next one. Okay, molten sodium fluoride undergoes electrolysis. If it is a molten, you do not have the water ions. Okay, so now let us do the same experiment again. Okay, now it's a molten. So let me erase this. So if it is a molten, you only have sodium and fluorine ion. Okay, so what will happen at the anode side? Okay, at the anode side we will have a fluorine being discharged. Okay, fluorine will appear as a Dewey atom, so not to forget to put here. So here we will have a fluorine gas, and at the cathode, here we will have a electron, and we will have a sodium. So the sodium will be deposited at this cathode. Alright, so we will have a fluorine and we will have a sodium. So here we will have a fluorine gas, and here's a sodium. Okay, now write the ionic half equation for the reaction at the negative electrode cathode. So they are referring to this sodium. So it will be accepting one electron to form sodium metal. Okay, so this is how you answer the question. Okay, now let us move to the next point. Okay, E, complete the cross and dot and cross diagram to show the electron arrangement in the molecule fluorine. So fluorine, it has 9 electrons and you have that 2.7. Okay, 2.7 the electron arrangement. So they need another one more. So let me make this one bigger. So we will have fluorine. We can draw with a Lewis structure first. Okay, so this fluorine you have cross and this fluorine you have a dot. Okay, so now if we label this, we will have like this, and they do have a single bonding. Okay, so this is what you have to draw. Okay, wait, let me choose. Okay, this is what you have to draw over here. There's a dot and cross in the middle. So here we will have 7, and the dot you have another 7. Okay, so this is how you answer this question. Okay, so it's 1 mark. So now let us move to the next one. Okay, so the melting point and boiling point of fluorine and sodium fluoride are shown. Deduce the physical state of fluorine at negative 195. To explain your answer, okay, physical state. Okay, so melting point and boiling point. So here will be the solid, liquid and gas. So the melting point of fluorine is negative 220. So they are asking the state of physical state of fluorine at negative 195, which is slightly higher, which is about here. Okay, this is negative 195. So which means it is still in the liquid state. Okay, because you can mention that your explanation, the melting point of fluorine is below. Or you can say higher is higher than yeah, sorry, it should be below. Okay, is below the temperature of the fluorine. Okay, sorry for my bad handwriting. Okay, so this is your answer. Okay, now we move to the next one. Okay, explain in terms of structure and bonding why sodium fluoride has a much higher melting point than fluorine. Explain. Your answer should refer to the type of particles held together by force of attraction, type of force of attraction between particles, relative strength of the force of the attraction. There's 3 marks here. So you could answer like sodium fluoride is in ionic bonding. Okay, however, the fluorine is in a covalent bonding, a weak covalent bonding. So let me write down this answer. Okay guys, so this is my suggestion answer. Okay, so sodium fluoride has a strong ionic bond between its particle and it needs high energy to break the bond. Okay, and fluorine has a weak covalent bonding between its particle and it needs little energy to break its bonding. Alright, so this answer is sufficient for you to get 3 marks. Okay, now let us move to the next question. Okay, number 4, hydrogen iodide decomposed into iodine and also hydrogen, the reaction is reversible. Okay, a gas strange contains a mixture of a hydrogen iodide, hydrogen and iodide. Gases were sealed. After reaching equilibrium, the mixture was a pale purple color. After reaching equilibrium, so it means, okay, now if you look at this picture here, this is a combination of all these gases, and this, the end here is sealed, so which means that the end product, you can see there's a pale purple color, right? So it means the reaction is going toward the forward reaction. Okay, now let us answer the first question. State what is meant by the term equilibrium. Okay guys, for rate of reaction, this type of question, it will come out in 2020 few papers, 2019. Okay, check out these papers. So you will have there two main points which you must remember. So here, please remember these two answers, guys. So if we say equilibrium, it means that the rate of a forward reaction is equal to backward reaction. It means the hydrogen iodide to iodine and hydrogen is a forward reaction, and backward reaction is the opposite. Okay, it's reversible. And then another point here is the concentration of reactant and the product are constant. Alright, so let's move to the next question here. Okay, so now B, the plunger of a gas strange is pushed in. The position of equilibrium does not change. The color of gases mixture turns darker purple. It means that it is moving into a forward reaction. Okay, and then the temperature here remains constant. Okay, now explain why the position of equilibrium does not change. Okay guys, so it is because number of gas molecules, okay, gas molecule at the both sides here are the same. Okay, that is why the position of the equilibrium does not change. Okay, now suggest why the color of a gas mixture turns darker purple even though the position of equilibrium does not change. So here, if you notice this, the purple color is given by iodine. All right, so you can mention that the iodine particles are forced to be closer together. Okay, so this is your answer here. Okay, for C, the forward reaction is endothermic. It means this is absorbing the energy. Alright, so state what happened to the position of equilibrium when the temperature is decreased. So you can say the position of equilibrium shifted to the left. Okay, let me explain to here. Okay, now let's say it is endothermic. Okay, I give you like two scenarios. One is exothermic, another is endothermic here. Okay, for endothermic, what happened here is the reactant will be absorbing heat. Okay, so the temperature must be high and the pressure must be low. Okay, this is for shifting them to right. If it's left, okay, shifted to the left, which means it's the opposite side here. So the temperature should be lower and the pressure should increase. Okay, however, for the exothermic scenario, so let's say we have this. Okay, exothermic is they are releasing the heat. So the temperature naturally must be lower and the pressure must be higher for them to have a forward reaction. If let's say you want to have a reverse reaction, the temperature should be higher and the pressure should be lower. Okay, so please copy down this one. Okay, now we move to the next question. Okay, for this, state what happened to the rate of forward reaction and the rate of a backward reaction when the temperature of the mixture is decreased. So forward reaction will obviously decrease. Same goes to with the backward reaction. Okay, so this is your answer for this question. Okay, now let us. Okay, for number 5. This question is about salt. Salt that are soluble in water can be made by reaction between insoluble carbonates. All carbonates salt are insoluble except for sodium, salt, potassium and also ammonium. Yeah, so please remember this. And dilute acids. So zinc sulfate is a soluble in water. Okay, you are provided with a solid zinc carbonate and dilute sulfuric acid. Describe how you would make a pure sample of a zinc sulfate crystal. Your answer should include the practical details as well as how you would make sure that all dilute sulfuric acid has reacted and a chemical equation for the reaction. Okay, the marks for this question is 5 marks. Okay, here's the 5 marks here. Okay, so for the first step here, we prepare the equation first. Alright, so here we will have a zinc carbonate plus with sulfuric acid. Okay, so when you have a metal carbonate plus with acid, you'll be having here the salt. Okay, so just take directly from zinc and sulfate. So both will be 2 plus and 2 minus the power, and it will release carbon dioxide and water. So this carbon dioxide, you will witness the bubbles. Okay, after the equation, now we are going to in more details here. Okay, as you could see, they are asking the second point here, how you would make sure that all dilute sulfuric acid has reacted. So what you have to do here is, okay, this is the complete answer. So the first point here, add excess zinc carbonate into dilute sulfuric acid. It answers this question. Okay, you have to make sure all the acid has been reacted. That's why we are adding excess. And then we have to stir it until there is no bubbles. So it means the reaction has been completed with the given dilute sulfuric acid. So the balance here, we will have excess zinc carbonate. So we have to filter out the excess, and we take the filtrate, okay, which is zinc sulfate that is produced over here. We boil it until it becomes saturated. So this solution we have to cool and dry it until it forms the crystal. Then they have mentioned that we have to produce the pure sample, right? So please don't add this point. We have to wash it first. Okay, wash with water and repeat the process until it forms the crystal back. Alright, so I'm giving you the complete answer. This is you can use it for your paper 4 and also for your paper 6. Okay, so please copy this one down, and this is about 5 marks over here. Okay, I'm going to the next question now. Okay, some sulfate decomposed when heated. When hydrated, iron to sulfate. Hydrated means it contains water. So your equation will be, the formula for this here will be iron sulfate, and then you have a dot over here and you have a water molecules. Okay, so the number here depending on the equation. So when hydrated iron to sulfate is heated strongly, sulfur dioxide gas is given off. So describe a test for sulfur dioxide. Okay, sulfur dioxide has a very strong oxidizing, is a strong oxidizing agent. Okay, so the test here we can use is potassium manganate. Okay, this is a purple color. This is a purple color. Once it go through the sulfur dioxide, it will change to colorless. So you just have to add in here, this is a acidified potassium manganate. And here will be purple to colorless. Okay, number 2, complete the equation for the decomposition of hydrated iron to sulfate. So let me make it bigger. So here we will have 7 molecules. Here we have 2, okay, 2 iron. So we have to solve this one first. So we put here 2. Okay, so iron has been solved. Now we look at sulfate group. Sulfur, they have 2. So here is 2 as well. And if you look at hydrogen here is, this is 14 multiplied with 2. Don't forget this part. So we have about 24 hydrogen atoms, and here you have to put 14. Okay, now let us calculate the oxygen number to make sure it's correct. So here will be 7. So for oxygen here will be 7, and here will be about 4. So it's 11. 11 multiplied with 2, you'll be getting here about 22 atoms of oxygen. So here we have 3, here we have 2, here we have 3, and here we have 14. So all together when you plus, you'll be getting, here's 5, 3, here's 8, plus with 14, yes, 22. So your answer here is 2 and 14. Okay, so this is the answer for this. So you'll be getting here 2 marks and 2 marks. Okay, for C, some chloride are hydrated. When hydrated barium chloride crystal are heated, they give off water. Okay, they release the water. Okay, a student carries out an experiment to determine the value of X in barium chloride, hydrated barium chloride. Okay, hydrated barium chloride crystal are weighed. The hydrated barium chloride crystal are then heated. The remaining solid is weighed. Okay, and then describe how the student can be sure that all the water is given off. Okay guys, this is my answer suggestion. So we heat up the hydrated barium chloride and then we weigh it. Okay, and then we repeat the procedure, until it reaches a constant mass. Okay, until it reaches a constant mass. So that's how we know all the water has been given off. Okay, so now we are going to do the calculation part here. Okay, here I copy down the equation. So now in an experiment, 4.4 gram of hydrated barium chloride is heated until all water is given off. The mass of barium chloride remaining is 4.16. Okay, So to calculate the mole, we are going to divide, we take 4.16, the mass over here, and we divide with barium chloride. So they have given here barium chloride's RMM is 208. So when we calculate this, we will be getting 0.02. So 0.02 moles. Okay, so now if you look at here, this is 1. The ratio here is 1, here's 1, and here's 1. Okay, so this is 0.02. So now if they're asking to calculate the mass of water given off, okay, so we just have to take the 4.88, the initial value, minus with the dry barium chloride. So we'll be getting here about 0.72. So the weight here is a 0.72. So they're asking us to calculate the mole number. So here we take the mass and we divide with its RMM. So here we'll be getting 0.04. Okay, so this is the mole. So the mole over here will be 0.04. So supposedly here will be the mole is 2. Okay, the mole is 2. So the X here automatically will become a 2. So this is a 2. So the total marks for this question is 15. Okay, now we move to the next question. Okay, this question is about metals. Iron is extracted from its main ore in a blast furnace. Okay, let me explain to you the entire process of this blast furnace first. Okay, for blast furnace, this is the raw material. We have choke, and we have hematite, iron oxide, and we have a limestone, which is a calcium carbonate. So okay, so the first process will be starting with the carbon. This is carbon. So carbon will be heated up with oxygen. So here you'll be getting here carbon dioxide. So this carbon dioxide is a normal gas. So what happens here is the carbon dioxide will be further having a reaction with carbon to form carbon monoxide. Okay, this is a very strong reducing agent. Okay, the carbon monoxide is a very strong reducing agent. Okay, now let me explain to you about a limestone. So what this limestone will do, they will decompose. Okay, they will be thermally decomposed to have calcium oxide and also calcium carbon dioxide. So this carbon dioxide will be as a fuel for this process. And the second process is because this reaction is very exothermic. Okay, it is a very exothermic, and it is also one of the heat supply for this process, the second equation. Okay, now hematite, the iron oxide, will have a reaction with the carbon monoxide. So you will have here iron plus with the carbon dioxide. Okay, so hematite is an ore, so they do contain silicon oxide. All right, silicon dioxide. So what happened, this is like an impurity for this. So that is where the function of calcium oxide will come. So calcium oxide will combine with silicon oxide to form slag. This is a calcium silicate. This is a slag. Alright. So these are the main equation you have to remember for flash burners. Okay, now we go back to the question. I scroll down a little. Okay, now we can see here. Okay, number 1, chalk and iron ore are added at the top of the flask burners, which is the raw material. Name one other substance that is added at the top of flask burners. So they are missing the limestone. Okay, name the substance that leaves the flask burners at A. So A is the most bottom. So here you will have iron coming out. Okay, here you will have the iron, or you can put here Fe, ferrum. Okay, now iron ore is mainly iron trioxide. Name a substance that reduces iron trioxide to iron in the flask burners. So we will have carbon monoxide. You can also say carbon. This is from the chalk itself. Okay. Now, temperature inside the flask burners can reach up to 2000 degrees Celsius. Name the two substances that react together in the flask burners to produce this high temperature. So the equation that I mentioned to you is the carbon and oxygen. Which is this equation, C carbon dioxide plus with the carbon, it will produce you carbon monoxide. So this process is very exothermic, so it produces a very high temperature. So name two waste gas that leaves the flask burners. So here we will have the waste gas is carbon dioxide, and also you will have here nitrogen. Okay. So B, zinc is extracted from a zinc blende. So zinc blende is zinc sulfate. Okay. The main name the main zinc compound that is present in a zinc blende. So here we will have here zinc sulfate. Okay. When the zinc is extracted, it forms a gas. Gaseous zinc is then converted into molten zinc. So the change, so this is a gas, okay, this is the gas and this is the liquid. So name the state of this physical change. So here we will have a condensation. Okay, now C, name the alloy that contains zinc and copper only. So you can say it's a brass. Okay, now the next one, D. Copper has the following properties. Okay, give two properties from the list in which copper differs from group 1 element. Okay, please remember, group 1 element, even though it is a metal, it is soft and it has a low density. Okay, it has a low density, so we have to select the high density and also okay, so this has been answered, and soft and here should be harder, but there is no harder here, but we can select another one, which is it has a variable oxidation state. Okay, high density and it has variable oxidation state. So this is your two answers over here. Okay, now The another one, give two properties from the list in which copper is similar to group 1. So we can say it is a good conductor of electricity and it forms a base oxide. Okay, this is for the second one. Alright, so it's a easy question. So the total is about 13 marks over here. Okay, now for number 7. Many organic compound contains carbon, hydrogen and oxygen only. A, an organic compound R has a following composition by mass. So here, let me do a calculation here. Okay, so they are asking the empirical formula. So the percentage is, you can make it equal with the mass. So here we have 69.77, this is carbon, and hydrogen here we have 11.63, and oxygen we have here 18.60. Okay, now we have to find the mole by dividing their RAM. This is 1 and this is 16. So we will be getting here is about 5.814. Hydrogen remains the same, and here oxygen here will be 1.1625. So we have to take the smallest, okay, the smallest mole and divide it with all. So here will be 1.1625, and this is the mole ratio. So here will be getting 1. And here will be getting 10. And here will be getting 5. So your answer here will be C5H10 and oxygen is 1. So this is your empirical formula. Okay, now we move on with the next one. Okay, compound S has an empirical formula of this. So it's a different question, so I can scroll down. Okay, now it has an empirical formula of CH2O and a relative molecular mass. This is the actual mass, which is 60, and they're asking for molecular formula. So here we just have to do a bracket with N, and we plus all the RAM. So here will be 12 plus with hydrogen 1, sorry, hydrogen is 2, plus with 60. So here we will have 14 and 30. So 30N equals to 60, and the N here you'll be getting as 2. So now just take this a 2. So your equation, your formula here will be C2H4O2. Okay, this is the formula, molecular formula. It's 2 marks. Okay, now look at C. Compound T and compound V have the same formula, molecular formula. This is C3H6 and O2. Okay, T is an ester and V has this is a carboxylic acid. Okay, and state the name given to the compound with the same formula, molecular formula, but different structure. So this is called as a structural isomers. Or you can just simply put here is an isomer. Okay, name the homologous series that V is a member of. Okay, once you have this group, all right, so it is a carboxylic acid. Carboxylic acid. Okay, this is your answer here. So let us move on. Okay, number 3, draw a structure of compound T. Show all the atoms and all the bonds. Name compound T. So let us refer back to here. So the T here is given, they have a same molecular formula. So 362. So here we have here 3, 6 and 2. So what is T? So T is an ester. Okay, T is an ester. So ester, please remember. Okay, let me just give you a revision of what is ester. Oops. Okay, so here ester is the combination of an alcohol. So alcohol, let's say we have what is this? This is a methanol. Okay, this is a methanol, and let's say I'm going to use butanoic acid. Example, butanoic acid. So we'll put here C. Okay, please remember the formula in case you forget this. COOH. Okay, and then this butanoic is actually C equals to 4. The carbon is 4. So here we have to minus 1 because here we already have another carbon. So C3 and H will be 7. Okay, so look at here. This is one type of condensation polymerization. Okay, so here's the OH and here's the H. So what happened now is both of these will form the water. So you will produce the water, and this structure is C3H7COO. Okay, this is from the acid, and from the alcohol you will have CH3. Okay, so if you're looking at the structure, so just remember this, and this is the alcohol part. Okay, I'm not going to draw this hydrogen. Okay, never mind. So we will have this hydrogen. Okay, this is the structure. In terms of naming, you have to name the alcohol first, which comes under methyl. Okay, methyl. And then look at the acid. We will have a butanoic acid, right? So here will become butanoate. Okay, so you have a methyl butanoate. So remember, ester, you will have this. You will have this part. Okay. Okay, guys. Hope you have a small revision on the ester. So here we have is ester, right? So compound T is a ester. So what we can do now? You must have this, right? So they are asking for the structure. So one C already have here. So it's up to you whether you want to put 1C here or 2C over here. So here we have here we have a limit of the 3C. So we can put here 1 and here 1. Alright. So the rest here will be the hydrogen. Okay, in terms of naming, this section will be under acid. Okay, so this is it is from ethanoic acid. Okay, ethanoic. So here will be ethanoate, and from the alcohol part, this is 1C, so it's methanol, so we can put here methyl ethanoate. So that is the name. Okay, so please remember this is a methyl ethanoate, or we can change this. All right, so we can change this. Let's say you want to put another another carbon over here. So I'm going to erase this part. Okay, so let me place, I should have erased this. Okay, let me place another carbon over here. So here you have hydrogen and hydrogen at the both side. So this is also accepted because you obey the formula. So here you will have methanoate from the acid, and this is a ethyl. So your full name here will be ethyl methanoate. Okay, now draw the structure of compound V. V is a carboxylic acid. So here we have 3, so it means that 1, 2 and 3. So this will be, you have 3 C's there. So here will be a propanoic acid. Okay, propanoic acid. Okay, so I hope you can understand this drawing part. Okay, now for the D, the last one, last question for this paper. Okay, D, ethanol can be produced from long chain alkane. Okay, from a long chain to ethane, and here will be cracking process. Okay, so here we have C, carbon 10 and H22. Okay, now the first step, let me complete the first step first. Okay, this is cracking process as I explained to you, and the equation C10, okay, C10H22, and they will form, one is a alkane, another one they will form is a alkene. So here is a ethene. Ethene is C2H4. So if you minus this, you'll be getting here 8, right? And then here will be 4, 22 minus with 4, here will be getting 18. So this is alkane. So you can check with the formula of alkane and alkene. Okay, now ethene to ethanoate. Ethene to ethanol. So this is alkane to alcohol. So this is hydration. Hydration, which is you are adding the water. So your equation here will be C2H4 plus with water, and you'll be getting ethanol. Alright. Okay, this is 4 marks, and total for this question here is 15 marks. Okay guys, so all the best for your revision and also your exam. So I wish you learned something from this video. Good luck, groups. Move to the next one.